Hi everyone! Today we're going to be learning the basics of row number, which is one of my favorite window functions. It's honestly the window function that I use most frequently as a data analyst in tech, and it's also one of the most commonly asked SQL interview questions for data science and data analytics, so you better know it. If you're new here, I'm Jess Ramos. I'm a senior data analyst in tech, and I'm also a content creator on all the different social media platforms, and I'm the founder of Big Data Energy. I create content on data analytics, SQL, and just cool career stuff, so definitely follow along and subscribe for more. In my opinion, row number is the most useful window function that you could learn because it's used in so many different business problems. I mean, I'm always ranking things at work in SQL. A lot of times I'm ranking orders based on their timestamp or number of customers, blah, blah, blah. I'm always having to rank things and then pick the most of something. And that's where row number is really useful. And yes, I know there are two other window functions in SQL that also help you rank. There's rank and dense rank, but if I'm being honest, I use row number 9 times out of 10 because it suffices in most situations that I need to rank things for. I'm generally not that concerned about ties and super preciseness. I'm basically just looking for a quick rank, grab the top one, and that's it. So that's why I love row number. It's easy to use and it's applicable to most ranking situations. So if you're gonna take the time to learn one window function and learn it really well, I recommend row number because you're gonna use it all the time on the job. It's gonna show up in live coding interviews and it's just a great window function. Okay, so if I haven't already convinced you enough how awesome row number is, let's dive in and learn how to use it. All right, let's get into row number and do a practice problem. It's honestly my favorite window function, so I'm so excited to show y'all how to do it. And I did find an amazing data set for us to use today. It is a Taylor Swift Spotify data set. So I have this little Python script here that's just reading in this Excel file I have and renaming it Taylor. So if you don't understand Python, it's okay, just ignore this part. I'm only renaming the data set Taylor so it's easier for us to call on in our queries. So if we run this, we can see the entire data set, and let's just do a quick little select star, select star from Taylor, just as a little check to make sure that our data imported good and we're all ready to go. All right, so here is our output. Select star from Taylor is gonna pull the entire Taylor Swift album. So we can see that we have a song for every row, and it tells us what album the song is on, its danceability score, we're gonna need this for later, the energy level, and all these other fields that we're honestly not gonna use today, so don't worry about those. So let's say that we wanna pull the top or the most danceable song on every album. And generally, when we have a business question that says most or top, a lot of times we're gonna need to use the aggregate function max because we wanna find the maximum of something. In this case, we wanna find the max danceability, and thank goodness for this autofill because I don't know how to spell danceability, and we also don't need these double quotes because, yeah, we just don't need them right now, but we will need them later and I'll explain that. Okay, so we're gonna take the max danceability and rename this as the most danceable. So we're gonna do the max by every album. So we're gonna have to group by or segment by every album and then take the max danceability per album. So group by album, but we do actually have to have album in the select statement if we're grouping by it. So let's also pull in our album name, comma, and this is gonna pull us the most danceability, the max danceability score per album. And we can also just say 1 here because album is the first column in the select statement. So a shorthand notation is group by 1. And this is what I prefer to use. It gets you the exact same thing. Okay, so now we have the max danceability per album, which is great and all, but like, what does this mean? This doesn't really give us any information. We don't even know the song title. I mean, we at least need to know the song name so that way we know which one is the most danceable, right? So let's try to pull in song name and see what happens. So we have song name, don't forget your comma, and yes, we do need double quotes around song name because it is a column name that is 2 words. So a way to tell SQL that it's a column name is to put double quotes around it, and that way it won't get confused with you putting 2 words there. And typically it's best practice to use underscores or just anything else to make all of your column names 1 word, but if you were unfortunate enough to get a column name that is 2 words, double quotes is the way to go. All right, let's just see what happens here. Uh-oh, an error. And the reason for this error is because if you put a column in the select statement, it also has to be in the group by statement or aggregated. And we don't want to aggregate it. That doesn't really make sense. Let's try group by. Let's see what happens. So we're going to add 2 and also group by the second column in the select statement. So now we're grouping by album and song name. Well, that's weird because now we have the album and the song name and a most danceable score, but the most danceable score isn't actually finding us the max per album like we wanted. And the reason why is because we're grouping by album and song name and taking the most danceable within all those options. And for every album and song name combination, there's only 1 option. So it's literally just taking that danceability score and saying it's the most danceable. So we're actually grouping by too much here. We really do only want to group by album, but there's not a way to group by album and also pull in the song name so we know what song it is. And that, my friends, is why we need row number and window functions to accomplish this question. So let's just backtrack a little bit. Let's get rid of group by. We don't need that anymore. Let's also get rid of max danceability, and we're only going to keep the album and the song name. So what we're going to do is we want to go within each album and rank all the songs based on danceability. Let's also pull in danceability so we can kind of see what's going on here. So what we want to do is we want to go to each album and rank all the songs based on their danceability and choose the top danceable song and also pull in that song name too. And if it's kind of confusing, this album is called Taylor Swift. It's her debut album, her very first one. So it's the artist name, but it's also her first album name. Okay, so what we're gonna do after our album, our song name, our danceability, we're gonna add our window function. I'm just getting rid of those unnecessary double quotes just to kind of clean things up a little bit. Our window function we're gonna use is a row number because we're gonna be ranking our songs based on danceability. And typically in SQL, when we wanna rank things, we are gonna either use row number, rank, or dense rank, and they all do like pretty much the same thing. They just have little like caveats in the way that they label the rows. I'm not gonna break those down in this video because this video is introducing row number and ranking, and I'm just not gonna open that can of worms, but definitely look up the differences between the 3 after this video. So we're gonna start out with row number, which is going to assign a row somehow, but we have to tell SQL how to do that. So next we're gonna follow with over. And with window functions, you're typically gonna use partition by something and then order by something. You don't have to use partition by and order by in every window function. It just kind of depends on the circumstance and what you're trying to accomplish. But this is basically the general formula for all window functions. So I like to write this out like a formula and kind of ask myself a few questions as I'm thinking through the window function. The first question is, what are we calculating? In this case, row number. We're ranking, we're trying to sort things and give it a row number. So our first thing is row number. That's what we're calculating. The second question I like to ask with window functions is, are we partitioning by anything? Should we be partitioning by anything? In this case, the answer is yes, because we need to partition by every album. We need to segment the data by album. We're gonna take everything from the Taylor Swift debut album, put it over here, and then determine a row number. And then we're gonna take the Fearless album, put it over here, sort, determine row number. And then we're gonna go to Speak Now, put it over here, partition, sort, give it a row number. So we are partitioning by album because we're going to do this calculation for every single album separately. So I'm gonna put album in here. Again, getting rid of these pesky double quotes. I wish it would stop adding those because we don't need them. And how is it gonna know how to determine the row number within each album? How do we wanna do that? And the answer is that we need to order by something. So what are we ranking by? What are we ordering to do the ranking? We're ordering danceability. So we're gonna order our data set by danceability within each album and assign row numbers that way. And the default for ordering by is ascending. So that means it's gonna put the smallest at the top and the largest at the bottom. So for ordering by danceability, it's gonna put the least danceable songs at the top and the most danceable at the bottom and assign row numbers that way. But what we actually wanna do is, instead of going with the default argument here, we're gonna add descending at the end. So that way it's gonna order in descending order and put the most danceable songs at the top for each album. And the reason why is because we want a consistent row number for every single album that clearly labels the most danceable song. So if we order danceability in descending order, and for every album, the most danceable song is at the top and has the row number 1, it's really easy to identify for each album which of the songs is the most danceable. After that, I'm going to just rename this new window function column I just made as danceability rank, because that is the danceability rank for that album. And now let's try to run this and see what happens. Okay, so now we still have all of our individual songs. So we definitely have way more data than we really need, because we only need the top most danceable for each album, but we can clearly see how this calculation is working. So let's just look at Midnights, for example. So we have our Midnights album, which has 13 total songs. And we can see here that they're all ranked in order from most danceable with a danceability score of 1 all the way down to the least danceable song. And of course, Vigilante Shit is number 1, the most danceable on the album. I mean, there are no other songs on that album that are more danceable, in my opinion. Vigilante Shit, best. And it's doing that same process for every album. So for every album, it's gonna start with a danceability rank of number 1, go all the way down to the last song in the album, and so on. And that process is repeating for every single album. So now we need to filter for the most danceable song per album. So, what if we just filter and take all the danceability rankings of 1? So we get Vigilante Shit from Midnights, we get the 1 from Folklore, even though Folklore is not a very danceable album, sorry I said it. And then we get Hey Steven from Fearless, and we just take all the danceability ranking scores 1. So in SQL, we know that we can filter with the where clause. Let's just try it out and see what happens. Let's take our danceability rank column, put it in our where clause equals 1, and boom, error message. The reason why is because you can't actually put window functions in the where clause. So you can't filter for window function conditions in where. And it actually comes down to the order of execution for SQL. So in SQL, where is actually performed before select, because SQL wants to filter out as much data, as many rows as possible before doing the columns and your select statement. So by filtering for danceability rank equals 1, we're actually doing this before the select statement is even done, which is before the danceability rank window function is even calculated. So we're basically calling on something that doesn't exist yet in that point in time, which is why we're getting this error. So there's a super secret weapon that you can use for filtering based on window function conditions. And that, my friends, is qualify. So qualify is basically like a where clause, but for window functions. So you use it just like the where clause. You type qualify, and then you put your condition. So danceability rank equals 1, because we want to filter for the value 1 in that column. Now let's run this, and boom. Now we have, for every single album, the top most danceable song and the danceability score. And we can see that they all have a danceability rank of 1, because that's what we filtered for using qualify. So if I were gonna have a Taylor Swift dance party, this is the playlist I would do, because it's the most danceable song per album. I also do want to note that qualify is not available in every SQL platform and dialect. So it's available in like the newer cloud platforms like Snowflake, BigQuery, cloud-based data science notebooks, all the cool fancy stuff. But if you're using SQL in a more like traditional, clunkier IDE that maybe doesn't have like these updated cool things like SQL Server, MySQL, dbeaver, you probably can't use Qualify. So it's definitely good to learn whether you can use it in your work environment or not. But I do just want to point out that if Qualify isn't working for you and you're getting an error, it's not available everywhere. But if you're unable to use Qualify, you can actually turn this part right here highlighted into a CTE, rename it as a, whatever CTE name you want to use, and then in a separate select statement below, you can do where danceability rank equals 1. So you have to predefine your CTE with your danceability rank column, and then you can filter with a where clause below that as you normally would a regular table. So that's a little workaround. All right, whether you were here to learn row number or get a list of Taylor Swift's most danceable songs per album, I hope you got what you needed out of this video. Thank you so much for watching and subscribe for more.